Welcome back, everyone. We are on notes number 18 today, and today we're going to be looking at whether a derivative is positive, negative, or zero. This is more of a conceptual thing, more of a graphical thing, not so much an algebraic thing today. It's really important. So let's say we have some function that's increasing. So it could look something like this. I'll call that f of x. Well, what would its derivative be like? Remember, the derivative is the slope of the tangent line. So I'm going to draw a few tangent lines, just kind of rough sketch here. There's one, it would have a positive slope. There's one, it has a positive slope. There's one, it has a positive slope. Anytime the function is increasing, the slope of the tangent line is positive. Even if I draw it like this, more of a concave up sort of thing, if I draw some tangent lines in there, you're going to see these are lines with a positive slope. So, if f of x is increasing, f prime of x, the derivative, is greater than 0. Now let's look at what happens if f of x is decreasing. So it could be like this, kind of concave up. Could be like this, kind of concave down. Let's sketch a few tangent lines. So we could have something like that, something like that. Okay, all of those have a negative slope, and the same for these tangent lines. Sorry, that one wasn't tangent. We'll try that again. If f of x is decreasing, f prime of x, the derivative, is less than 0, negative. Okay, and then the other option, let's say I have something that increases and then decreases. Well, you're going to have lines with a positive slope. On the increasing side, you're going to have lines with a negative slope on the decreasing side, and what happens in between, there's a point, oops, that didn't look horizontal, there's a point where there's a horizontal tangent line, and we know the slope of a horizontal line is 0, so f prime equals 0 at a maximum in this case, or it could be at a minimum. A place where the derivative is changing from being positive to negative, or from being negative to positive. And I guess you could say there's another possibility if your function is just constant, or maybe has a section of it that's constant, so it's a horizontal line, then you would have multiple points where the derivative is 0, because the tangent line is horizontal for all of those points. And then, of course, you could have a function that has a combination of these things. A lot of our functions do. Maybe they increase for a while, decrease for a while, and so on. So if you have this part here where the function is increasing, the derivative is positive. And then if you have this section over here where the function is decreasing, the derivative is negative. And then more increasing over here, so positive derivative. In between, horizontal tangent line, derivative equals 0, derivative equals 0. Okay, that's all the notes you have to take, but what I'm going to do for the rest of this video is to walk you through my open math number 9. And your problems might have different slight variations compared to my problems, but they're going to be very similar. So my open math number 9, question 1. At the point shown on the function above, which of the following is true? The derivative is 0, the derivative is positive, or the derivative is negative. Well, that point shown there is on a section of the graph where the graph is decreasing, so the tangent line would have a negative slope. So f prime is less than 0. Question number 2. At the point shown on the function above, which of the following is true? F prime is negative, f prime is positive, f prime is 0. Same idea. This point happens to be on a section where the function is decreasing, so the slope of the tangent line is negative. So this one happened to be just like number 1 for me, but for you, the point's going to be in a different place, so it's not necessarily going to be the same question twice. Question 3. Which blue function is the graph of the slopes of the red function? Okay, so the red function is like our f of x. What do we know about the slopes? The slopes are the tangent line, the slopes of the tangent line or the derivative is what I'm trying to say. So let's imagine our tangent lines here. They're all going to have the exact same slope, and they're all going to have a positive slope. So we're looking for a starting place where we have a positive value, a value above the x-axis. So this one's positive, and this one's positive, and this one's positive. So we can eliminate b, e, and f. And then for the other side of f of x, now we have a section where we have negative slopes, and they are all the same. So we need the next section to be negative below the x-axis, which is true for A and C and D. So the next thing we need to consider is how these are spread. So notice in part A that they put an equal distance roughly between the height of that and the height of that, between that and the x-axis. So maybe this is at a height of 2 and this is at a height of negative 2. Or maybe this is at a height of 1/2 and this is at a height of negative 1/2. They're fairly similar. However, on part C, notice how high this one is, and this one is close to the x-axis. So maybe this is up at a height of 5 and this is down at negative 1. And then notice on D, this is really close to the x-axis, this is really far away. So maybe this is at a height of 1 and this is at a height of negative 5. So what do you think for our graph? Would you say that these slopes here are the same steepness as these slopes over here? I would. So these positive slopes and these negative slopes have the same steepness. So that could be like 1/2 and negative 1/2, 2 and negative 2, something like that. But they're the same. So I would say that this is A. Question 4. The graph of the slopes of the red function has which color? Okay, so the red function is the one that we are finding the derivative for. What do we know about the slopes? Over here, the tangent lines have positive slopes, but they are getting smaller as we head toward a slope of 0. So we need positive numbers getting smaller. And then right here is where we need it to be 0. And then the other side, if we draw some tangent lines, they have negative slopes, and these lines are getting steeper. So we have negative numbers for our slopes getting, we can say getting bigger, meaning getting farther from 0. Technically, that would be smaller, but like negative 5, negative 6, negative 7. Okay, so then when we look at these 4 lines that we have to choose from, there's only one that is 0 right here. And that's the green one. Notice that it has positive numbers getting smaller, and then after the 0, it has negative numbers getting bigger. So the green one is the one. Question 5. The graph of the slopes of the red function has which color? So same kind of question, but this time more curvy. So what do we notice? We have negative tangent line slopes until they reach 0 right about here. and then we have positives until they reach 0 right about here, and then we have negatives again. So we need a function that's negative, and then 0, and then positive, and then 0, and then negative. So let's see where those zeros are. Right about here, and right about here. So it's definitely not the blue one. It's either the green one or the orange one. No, it's either the black one or the orange one. It's not the green one either. It doesn't have the right zeros. The black one and the orange one both have zeros right here and zeros right here. So which one is negative? Because those were negative slopes, and then positive slopes, and then negative. The one that's negative, and then positive, and then negative is the black one. Number 6 is like number 3. So notice we have positive slopes over here, and we have negative slopes over here. So we want one that's positive first and negative second. Positive would be above the x-axis, negative would be below. So eliminate that, eliminate that, eliminate that. Now think about the steepness of these two sections compared to one another. Which one is more steep? This one is more shallow on the left, this one is more steep on the right. So the negative slopes are actually going to be farther from 0, and the shallower ones, those are going to be closer to 0. They're not the same, so it's not A. The ones that are steeper when they're negative, farther from 0, that would be D. Question 7. This is the graph of a function f of x. On what interval is the function increasing? The answer has the form a comma b, where a equals what and b equals what. On what interval is the function increasing? Okay, well, they didn't put any arrows on the end, but I'm going to assume, and when you type your answer into My Open Math and check to see if it's right, you'll know if this assumption is correct. I'm going to assume we're going on to negative infinity. So I'm going to say increasing is this part. So that would be negative infinity to 3. I don't mean 3, do I? I mean negative 3. Negative 3. Those are the x values for which the function is increasing. On what interval is the derivative negative? Derivative f prime of x less than 0, negative. Okay, the derivative is negative when the function is decreasing because that is when it has negative slopes, like this. So that would be from the x value of negative 3 to, we're going to assume that it just keeps going even though they didn't put an arrow on the end. So negative 3 to infinity. Question 8. This is the graph of a function. Choose the graph of its derivative from among the following functions. Okay, so what we notice about the function is that it increases and then it decreases. So its slopes would be positive, so the derivative would be positive. And then, for a moment, the derivative equals 0. And then, after that, the slopes would be negative, so the derivative would be negative. So we need to find one that goes from positive to 0 to negative. This one down here is just negative the whole time. It looks like it's at negative 2, so it's not that. This one up here goes from being positive to 0 to negative, so it's a contender. This one here goes from being positive to 0 to negative to 0 to positive, too much going on. And this one here goes from being negative to 0 to positive. That's not what we want. So the only one that fit was the first one. So I guess we fill in the bubble. Okay, so hopefully that will help you work through your My Open Math number 9. Thank you, everybody.